So for each of these, we're going to sketch the graph. Now, in A, we have a vertical stretch, y values by 3. So when you go to change that, actually I'm going to give a preamble to this. We've now looked at four different transformations. Actually, we haven't done the plus d yet. We're going to do that one when we get to example C. But if you list them all for sine and for cos, we're not going to worry so much about tan right now. Shortcuts, we've noticed that the A value affects our amplitude, because that's vertical stretches and compressions. We're going to notice that our B value, that affects our period, because that's a horizontal stretch or compression. Your C value shifts things left and right. That affects where your starting point is. So all along I've said, where does cos graph start? It starts at a maximum. Where does a sine graph start? It starts on the sinusoidal axis going up. And our D value is going to shift things up and down, but we're really going to talk about that's the only thing that's going to affect your sinusoidal axis, shifting it up and down. Those are going to develop our shortcuts all together. In our next section, we combine them all. But right now, okay, we have an A value, a vertical stretch, your Y value by 3. That's going to change your amplitude. And so your maximum is now 3. Your minimum is now negative 3. Your center line stays at y equals 0. It's not going to affect your period, so we can still label one period and divide it into 4 equal sections. And a cos graph starts at a maximum, and you go maximum, center line, minimum, center line, maximum. Now normally you would draw it like this and add arrowheads on the end. Okay? But this question, when we reread it again, it says sketch for this domain from 0 to 2 pi. So now we would have to go back and say, oh, I need to erase this up to here and erase this and up to there, because I'm only going from 0 to 2 pi, no arrowheads. Okay? This is something typical of your textbook. On the exam, it's typical that your exam would say for at least one period. So if you drew it and stopped, you'd get full marks. If you drew it and put arrowheads on it, you'd get full marks. So your exam, I would say, is more in thinking, how can we benefit the student as much as possible? And not, you know, even though there's some details on there, you're like, oh man, they were really trying to catch me there. But for the most part, they're thinking of your benefit. Sketch one period. Okay? Second one, y equals sine 3x. That's going to be a horizontal compression. That's going to multiply your x values by 1/3. Remember that your period formula is 2 pi over your b value. So in this case, our period is going to be 2 pi over 3, which makes sense because if your period was 2 pi and you're multiplying x by 1/3, your new period would be 2 pi over 3. But the period formula figures that out for you. So now when you go to graph this, I'm going to label 2 pi over 3 here and label 2 pi over here, because we're supposed to graph between 0 and 2 pi. Normally on your exam, you would just label the 2 pi over 3. That's one full period. Always divide your full period into 4 equal sections, because those are your axes family. What's half of 2 pi over 3? Pi over 3. What's half of pi over 3? Pi over 6. Then for the third one, 1 pi over 6, 2 pi over 6, 3 pi over 6, which you could write as 1/2 pi. Okay, our maximum is still going to be 1. Notice there, like there's an amplitude of 1 in front and -1. And where does a sine graph start? Starts on your center line going up to a maximum, back to the center line, down to the minimum, back to the center line. Draw our center line on there if we like. So this would allow us to draw one period. If this was an exam, you would just need to draw this one period and add arrowheads. But in the textbook, they wanted us to graph all the way from 0 to 2 pi. So each of these would need to be divided into 4 sections. And you would just keep going. Maximum, center line, minimum, center line, maximum, center line, minimum, center line. And part of the reason they want to show you this is that normally from 0 to 2 pi is one period. With a 3 in there, now from 0 to 2 pi, there's 3 periods in that amount of time because you had a horizontal compression by 1/3. And finally, part C. This is our first question with a D value, something in the end. This is a vertical translation, 3 units up. This is the only thing that affects your sinusoidal axis. So if my sinusoidal axis is normally at 0, and I shift things 3 units up, I'm now going to have my sinusoidal axis at 3. Well, normally the sinusoidal axis was at 0, and we've shifted up 3 units, so now it's at 3. I would leave it there. I'd do it in a dotted line in red. That means it's not part of our graph. Hey, notice there's a 1 in front of, like it's not written, but there's a 1 in front of sine. And that A value was a shortcut for our amplitude. Our amplitude for this one's still going to be 1. So if your amplitude is 1, does it make sense that your new maximum is going to be 4 and your new minimum is going to be 2? And one of the things that we're going to do for our shortcut is we're always going to label our sinusoidal axis and use our amplitude to draw our maximum and minimum. The B value is 1. So our period is still 2 pi, and we're always going to take our period and divide it into 4 equal sections. Where does the sine graph start? On the sinusoidal axis. There's our start. Going up. So next, maximum, center line, minimum, center line. Which is just our parent graph. Oh, no arrowheads. Remember, this one stopped at 2 pi and stopped at 0. So this is where the graph begins and where the graph ends. So questions 6 and 7 for practice. And you know where we're going next is where we combine all 4 of these together in one. That's going to be our next section.